All right, my friends, it is your lucky day. I have contracted some kind of yuckiness and can't come to school. Even though I tested negative for COVID, I have to see if I test negative again. So I know you're like, woohoo, now I don't have to do anything. Not true. We don't have enough time left in the semester to extend the plan. So that means you need to watch the video, look at the filled in notes, use the answer key, use your brain, use your collegiate mentality, and make it happen. Stay on task, stay on schedule. So let's do these notes. They'll be super fun. Angles are measured in, and you know this already, either degrees, we talked about this a little yesterday, or radians. Not that many people know what radians really are. So a radian, 1 radian, you know degrees. You know there's 360 of them in the triangle. So they're like little teeny tiny slices. But a radian is defined as a situation where the radius, which we learned yesterday was 1, like here or here, is equal to the arc. This is like throwback to geometry that it creates. So in my picture, that means you rotate until you get to the point where this arc is the same measured length as these or this. They're all ones. At that point, you have traveled 1 radian. So clearly a radian is bigger than a degree because that you're not going to fit 360 of those into that circle. If you go 1 radian, 2 radians, 3 radians, you're almost to the halfway mark, which means you're only going to be able to go a little over 6 all the way around. 1 radian is equal to 57.3 degrees. Good little trivia thing to know. And you can see from the picture that that's about right. Like this size is about 57-ish degrees. So if you went just past 3 to get to 180, say you went to 3.14 or so. In the world of mathematics, that's actually known as pi. And that, my friends, is our conversion factor. Pi radians, so just a little over 3, is the equivalent to 180 degrees. So if you're like, I'm going to go pi radians, and I'm like, I'm going to go 180 degrees, we're going to end up in the same spot. This is your conversion factor. Just like if you're doing lengths, maybe you use 1 foot equals 12 inches. And you have converted units probably more than you want to think about if you have ever taken a science class in your whole entire life. So don't pretend you don't know how to do it. There's a couple of different ways. There's kind of a shortcut way, and then there's kind of a old faithful. Old faithful is cross multiplication. Just never fails. And so what you would do is you would set it up in a proportion. You would say radians compared to degrees. Now I'm going to know one of those. I'll be given radians and asked to find degrees, or vice versa. Okay, now I need to line up my conversion factor. Well, across from radians is the radian part, the pi. And then across from degrees is going to be the degree part, which is 180. So that's one way that we can solve these. So I'll show you how to do that down here. Let's say we want to set them up like that. Keep in mind that when you convert, you want your answers to be in reduced fraction form unless they come out as whole numbers. So if they're fractions of pi, which they typically are when you're changing them to radians, you just reduce the fraction, which if you remember, a super helpful way to do that is to hit math, enter on your calculator. That will reduce your fractions. So you don't have to like sit there and think about what is that if I reduce it. So let's do the first one using that conversion. Why is this not going to get bigger? There we go. Thank you. So this is clearly given in degrees. So when I set up my proportion, it's the radians that I don't know over 70 degrees. So like in this setup, one of these is going to be given, one or the other. And then this is always true. Pi radians is equivalent to 180. So I'm going to cross multiply because cross multiplying always works. So I'll have 70 pi equal to 180, and I'm just going to use the R, radians. But I'm trying to figure out how many radians it is, so I need to solve for that by dividing. That's gone. So the number of radians is going to be, and that's why I talked about this math enter business. I need to leave the pi, and I just need to reduce this. So I'm going to my trusty calculator. Whoa, it even has batteries. Cool. I'm going to type in 70 divided by 180, math, enter. And it reduces to 7/18, and I still have that pi. And you can either write it up top or you can write it next door. It doesn't make any difference. Okay, so that's kind of the old faithful way. Let's try that again down here, given radians. All right, I'm going to take, this gets kind of messy. So I'm going to take my radians, which is this, over my degrees, which I don't know. I'm using this again. And I'm going to set it equal to pi over 180. And I'm going to cross multiply. So pi times the degrees will equal 180 times 3 pi over 4. And the 180 was over 1, so I end up with all of this. So again, I can figure out this part on my calculator, but you have a pi on each side, so they cancel, which is good, because I'm trying to find degrees. Since I was given radians, I'm going to convert to degrees. So I'm just going to take my trusty calculator and do 180 times 3 divided by 4. And I get 135, and that is degrees, and the pi is gone. So if you're switching to radians, you should have a pi in your answer. If you're switching to degrees, you should not. Now, that is trusty way of doing it. But for those of you with kind of more of a shortcut math mind, it's not the most efficient. Let's pretend that we're in like chemistry. And you're doing, what is that, stoichiometry or whatever fun stuff. I'm sure some of you just like threw up in your mouth. But anyway, let's say that I start with degrees. I need to cancel the degrees. So the degree portion of my conversion goes on the bottom and the radian portion goes on the top. And that will cancel out and leave me with radians. So let's see that in action. I don't want you to do it both ways. I want you to choose cross multiplying because it's old or faithful and you know how to do it, or these kind of shortcuts. So let's find one that's in degrees, like this bad boy. 80 degrees. I'm going to multiply it by pi over 180. Keep in mind that's a 1. And I'm supposed to get it radians, which means the pi is going to stay in my answer. So I really just go ahead and reduce this fraction. I take my calculator and I look and go, okay, 80 over 180, math, enter, and it reduces it to 4/9. So my answer is 4 pi over 9, because that pi doesn't go anywhere because there's nobody to cancel it out. That is a shorter method. So let's keep using that if you can. You can always fall back on cross multiplying if you need to. I'd love for you to move towards the shortcut. So you start with 120, that's degrees. So when I set up my conversion factor, the degrees goes on the bottom, pi goes on the top. The 120 and the 180 needs to be reduced. 120 divided by 180, math, enter, and I get 2/3. But I still have this pi. So 2 pi thirds. You're going to see me always writing the pi as part of the top. It's not wrong to write it this way. I just think it's weird. Okay, so try a couple and choose whatever method. If you're like, nope, gonna do cross multiplying, then do it. I don't care. You just have to know how to do it. So we're still going to be having our quiz Friday. You want to be ready to do that. This is degrees. I don't care if it's negative. I still convert by putting the degrees on the bottom, so they'll cancel, radians on the top. There's nothing there to cancel the pi, so I know it's going to be in my answer. And just like every other problem using the shortcut, I'm taking negative 300 divided by 180. math, enter, enter. Not surprised that it's negative. You didn't change directions. You just changed to radians instead. So I get negative 5/3, but that pi is still there. So my answer is negative 5 pi thirds. Try 400. I want the matchy-matchy degree on the bottom, pi on the top. That pi is going to stay in my answer. I'm going to reduce this because this 400 is like over 1. So 400 divided by 180, math, enter, enter. It reduces to 20/9. So 20 pi over 9 would be the same as 400. Okay, so what's the shortcut going the other direction? The other direction, I'm going to start with radians. So all I do is flip over my conversion. If I'm starting with radians, I need to cancel that out. So the radians part goes on the bottom. The degree part goes on the top. Simplifying that, I'll get degrees. Oops, I missed one. Let me do this real quick. This is degrees. I put my degrees on the bottom. The pi is going to stay in my answer. These are going to reduce to negative 1 pi over 6. So you can write the 1 or not, doesn't matter. Okay, let's use this other way, which is really not that hard. I just take the radians and I multiply it by my conversion factor. But since I'm starting with radians, the radians go on the bottom and the degree part goes on the top. And then this is slick because these are gone. And then it's just a calculator thing. Negative 2 times 180 divided by 5. And that is negative 72 degrees. Now, these don't have to be on the unit circle like we talked about yesterday because we're not doing anything. We're just practicing going back and forth between the two things like you would practice going back and forth between Celsius, Fahrenheit, or Kelvin. Okay, this is radians. So I start with radians. I'm trying to get rid of that pi on the top, so I put mine on the bottom and put my degrees on the top. The radian part cancels, and I hit my calculator. 11 times 180 divided by 6, and 330 degrees. Okay, keep on trucking. I have radians, pi on the bottom, 180 on the top, pi's cancel. Calculator time, negative 5 times 180 divided by 12. That get me a negative 75 degrees. And it is degrees, so you want to label it as such. Pi halves. Pi halves times 180 over pi. Because I'm going from radians to degrees, I want to end up with degrees. Radians cancel. 180 over 2 lands me at 90. 2 pi is all the way around the circle, so think about that. Negative 2 pi, and then you're multiplying by 180 over pi, which is our conversion. That's like being over 1. So these cancel, and I get negative 360. So on the unit circle, the thing you did yesterday, I guess it would be, where you have to go to the right spot and find the right thing, go to the right spot, find the right thing. You're going to ultimately on Friday and next week have to be able to do that both in radians and degrees. So you want to practice this. The only way to be good at anything is to practice it. So you're supposed to be able to figure out the angles in radians and degrees and the coordinates. It's a lot, but the coordinates don't change. If I say to go to 30 degrees, you know where to go. All right, the top was 90. I'm just filling them in. 15 past that, 15 past that, and that's 30 shy of here. 30 more than halfway, because I only am going 15 to get into that middle. And then this is 240, 270, 30 more. Halfway is in the middle. And then I've got 330. This was 0, also 360. Keep in mind that these are 30 degrees away and these are 30 degrees, but you can see that these are closer. They're half of that. That's why there's only a space of 15 degrees on each of those. So from 0 to 30 is 30, obviously, but then from 30 to that middle mark is only 15. So get a handle on all of those patterns, because that's going to be the key to success. So right now, let's not worry about all the coordinates. Let's just figure out the radians. So keep in mind that this is like pi equaling 180 means that every place there's a 180, you can put a pi, and every place there's a pi, you can put a 180. So what are our most common angles? Well, one of our common angles is 30. All these 30s. So what would that be? Well, I have to put this in my conversion with the degrees on the top, or excuse me, on the bottom, so they cancel. I'm going to reduce the 30 over 180 and get pi over 6. So every 30 degrees is pi over 6. So what I do, and we're going to practice this tomorrow too, I go through and I go by 30 degrees, but I call them pi over 6, and I reduce as I go. So what does that mean? That means I'm skipping all the middles, because these are the 30 degree marks: 30, 60, 90, 120, 150, 180, and I just keep going. I'm basically ignoring all the middles because they're not 30s. All right, now we're going to do radians, counting by pi 6s, because pi over 6 is the same as 30. So this would be 1 pi over 6. The next 30 degree mark up here would be 2 pi over 6, but that reduces to pi thirds. The next 30 degree would be at the top, and that would be 3 pi over 6, but that reduces to pi halves. So I'm just filling in, what do these look like as radians? That's the world's worst pi. So 30 degrees is the same as pi over 6 radians. Then 2 pi over 6 reduced. 3 pi over 6 reduced. Here, 4 pi, think over here, 4 pi over 6 would reduce to 2 pi thirds. One more, I'd be at 5 pi over 6, but that doesn't reduce, so that's what it is. The next one would be 6, because I'm just counting pi over 6, but they cancel and give me pi, which is right, because I should be at pi by the time I get to 180. If I was on 6 there, this is going to be 7 pi over 6, and that doesn't reduce. Next, I'm at 8 pi over 6, which reduces. Oopsies, I got to scoot that over to my 30 mark, sorry. Because I'm ignoring all those middles for now. And at the bottom, I was at 8, so I'd be at 9 pi over 6, reducing to 3 pi halves. At the next 30 mark, I'm up to 10 pi over 6, which reduces. So all these that I'm using just to count, I don't keep them. I just use them until I reduce it, and then I'm going to be filling it all in. I was at 10, so this is going to be 11 pi over 6. And then all the way around is going to be 12 pi over 6, which reduces to 2 pi, which is all the way around. So if I do this, if I go by 30s and I count around and reduce, I have everything done except the middles. And the middles, my friends, are going to be odd pi fourths, because pi fourths, if I take 45 degrees and I convert it using my conversion factor, this reduces to 1/4 pi. So this middle mark would be 1 pi fourths. The top would be 2 pi fourths, but we already have that. The next one would be 3 pi fourths, which is why I said odd. So the next one I have to actually fill in is down here. 5 pi fourths, because this one was already filled in. It would have been 4 pi fourths and reduced again to being pi. Then the only other one is this one, 7 pi fourths. So, do you have to be an expert? No. By Friday, should you? Sure. So to become an expert, you have to practice. So there's blank unit circles somewhere in my room. All the worksheets that you need, all the notes that you need, everything is on my shelves behind the desk that's in the back corner of my room. On the left side, there's a pile on the right of the top and a pile on the left. And in there, you're going to see these notes, which I probably should have told you before. They're also on Schoology. And you're also looking for this conversion worksheet. Do you have to do it all? Yeah. Is it going to take you long? No. You're literally going down and doing each conversion. You do have to show your setup. So this is degrees. I'll go pi over 180. And then I'll reduce this on my calculator. 345 divided by 180. Math, enter, enter. I get 23 twelfths. But I still have that pi because I'm changing it into radians. So I should have my answers as fractions of pi. When I get down here, I'm taking my conversion factor and putting the radians on the bottom to cancel out what I already had and leave me with degrees. Pi's cancel. And again, on my calculator, 25 times 180 over 12. And now keep in mind it's negative, so it's still going to be negative because that's just telling you to head clockwise instead of counterclockwise. So you can pretend it's too much homework, but it's going to go really super fast. It's just calculator stuff. Help each other out. I'm sure there's an answer key. Don't be a cheater pants. Actually figure out how to do it. You're going to have a quiz on this week, test on it next week, and it'll be on finals. So just take the time to be knowledgeable, dig in, help one another, be good humans. And hopefully I get to see you soon because I really prefer to be at school, if you can't tell. Somebody ring the bell for me. Kind of miss it. Have a great day, and I hope to see you tomorrow.